Hello students, today we will discuss range of projectile by using y is equal to ax minus bx square and resultant velocity of a projectile body, and with what velocity the projectile body reaches the ground level and what is the direction of the final velocity of the body after reaching ground level. These topics we'll discuss today. So first one I'm discussing range of projectile body in terms of constants A and B. So in projectile motion, we know the relation. We know that y displacement of the projectile body along y direction, y is equal to ax minus bx square. And what is a in this equation? A is equal to tan theta and b is equal to g by 2u square cos square theta. So if you are taking ratio of these two, see a by b is equal to, so a value tan theta, just I am substituting value say b here, b value g by 2u square cos square theta. It means the denominator value I am writing in numerator 2u square cos square theta. But here tan theta is equal to sin theta by cos theta, sin theta by g into cos theta into 2u square cos square theta. 2u square cos square theta. So here we can cancel one cos, and after cancelling this cos value, so in numerator u square 2 sin theta cos theta, u square 2 sin theta cos theta divided by g. So but we know 2 sin theta cos theta is sin 2 theta. Then what we can write here, u square sin 2 theta divided by acceleration due to gravity g, which is equal to a by b. But we know it is u square sin 2 theta by is the range of projectile. So we can equate this value r. Therefore, what is shortcut formula to calculating range of projectile when equation is given in the form of a and b, ax square minus bx square, a by b. This is very useful formula to calculate range of projectile. So in terms of a and b. Next, resultant velocity direction I am explaining. Resultant velocity denoted by v. So we know this diagram very well. So it is x direction and it is y direction. Body projecting with velocity u. This is a trajectory. This initial velocity makes an angle theta with the horizontal, and we know this is the height of the projectile body. But at maximum height, velocity along y direction 0. But after particular time t second, so I'm resolving velocity component here ux and vy. So because velocity along y direction 0 at maximum height, so it is changes as uy to vy, and next the resultant of these two is along this direction v, and finally it makes an angle alpha with the ground level. Now after time t second, velocity of the body along x direction ux and velocity of the body along y direction vy I am calculating now. See first one, velocity along x direction. So I am using this equation, v is equal to u plus a into t. Velocity along x direction is equal to, what is the velocity along x direction? U cos theta we know. It is u cos theta plus, but we know acceleration of the projectile body along x direction 0. So therefore, velocity along x direction, how much we got? It is u cos theta. Similarly, velocity of the projectile body along y direction, Vy is equal to u now, u sin theta, but a is equal to minus z into t. So therefore, resultant equation means we know resultant magnitude of resultant of parallelogram equation. So by using that equation, an angle between these two 90 from diagram C. Therefore, theta is equal to 90 degree. Then resultant velocity v is equal to Vx square plus Vy square plus, so 2 into Vx Vy cos 90 I am taking. This is the resultant equation and we know cos 90 is equal to 0. No need to take the third term here because it is 0. Now substitute this Vx and Vy in this equation. So therefore, the resultant velocity Vx is V is equal to Vx value u cos theta whole square plus u sin theta minus gt whole square under root. This is the resultant velocity of a projectile body. Next to direction of resultant velocity. So direction, so tan alpha is equal to velocity of the projectile body along y direction by along x direction. If substituting this ux and vy in this equation, tan alpha is equal to vy value u sin theta minus gt divided by Vx value u cos theta. Then alpha is equal to tan inverse u sin theta minus gt divided by u into cos theta. So by using this equation, we can calculate alpha value. Right, next one small problem discussing now. If projection angle theta is equal to 45 degree, we have to prove the maximum height of a projectile body is 1/4 of its range of the projectile body. So according to this given problem, how much angle given here? Theta is equal to that angle of projection. Theta is equal to 45 degree. And we have to prove here the maximum height of a projectile body, h is equal to 1/4 into range. Now I am taking separately here these two equations, maximum height and range of projectiles. First I am taking say h value. So we know h is equal to u square sin square theta divided by 2g. So then h is equal to u square sin theta 45 here, sin square 45 divided by 2 into g. So therefore h is equal to u square sin 45 1 by root 2, then 1 by root 2 whole square divided by 2g. So therefore h is equal to here u square, this 1 by root 2 whole square is 1 by 2, then 1 by 2 into 2 1 by 4. So this 1 by 4 I am writing separately, 1 by 4 into u square by g. This is equation 1. So similarly, from range of projectile, we know r is equal to, it is u square sin 2 theta divided by g it is. Then r is equal to u square. If substituting theta value, so sin 2 into 45 divided by g. G is acceleration due to gravity, and r is equal to, it is u square sin 2 into 45 sin 90 divided by g. We know sin 90 value 1. So therefore r is equal to, it is u square divided by g. This is equation 2. So from 1 and 2, from equation 1 and equation 2, so what we can substitute in equation 1 from equation 2? In place of u square by z, nothing but range of projectile. Therefore, h is equal to, it is 1 by 4 into range of projectile. So finally, what is conclusion from this equation? The height of a projectile body is equal to 1/4 of its range of projectile when the projection angle is equal to 45 degree. Next, complementary angles. So if two bodies are projecting with the complementary, what is the relation between height of projectile bodies and range of the projectile bodies? So complementary angles, next topic. So we know complementary angles is nothing but the sum of two angles should be 90. So first one I am taking theta, second one I am taking 90 minus theta. If adding these two, we'll get 90 degree only. Next, see, I am taking here two bodies. If the two bodies are projecting with the same initial velocity, see, this is first body which is projecting with velocity u, and the maximum height of first one is h1. So this one I am taking h1. The projection angle is equal to theta. Now the second one is projecting with the same velocity u, and it makes an angle theta with the vertical direction. Then it makes an angle 90 minus theta with the horizontal now. So this angle 90 minus theta, and the range of this one is h2. Range of the second body h2. Right now, say first one I am taking the maximum height for the first body and maximum height for the second body. So for first body, maximum height h1 is equal to, it is u square sine square theta 1 by g 2z, which is equal to u square. Just I am substituting this theta 1 value here. U square sine theta 1 is theta sine square theta divided by 2z. This is the maximum height of the first body. Similarly, maximum height of the second body h2 is equal to u square sine square theta 2 divided by 2g, which is equal to, if substituting theta 2 value in this equation, it is u square sine square 90 minus theta divided by 2z. Then h2 is equal to u square sine square, so sorry, sine 90 minus theta cos, directly I am writing here, u square cos square theta divided by 2z. Now we got h1 and h2. If adding these two equations, h1 plus h2 is equal to, h1 plus h2 is equal to u square sine square theta by 2z plus u square cos square theta by 2z. It is u square cos square theta divided by 2z. So which one we can take common here? U square by 2z common. So therefore, h1 plus h2 is equal to u square by 2z, if you are taking common, sine square theta plus cos square theta. But we know sine square theta plus cos square theta is equal to 1. So what is the final equation now? h1 plus h2 is equal to u square divided by 2z. This is the relation between maximum height of two bodies when the two bodies are projecting with complementary angles. Next, range of projectile. Similarly, I am calculating. First one, range of the first body r1 is equal to, it is u square sine 2 theta divided by 2z, sorry, g it is. So directly substituted here, in place of theta 1 is theta here. And similarly, second one, r2 is equal to u square sine 2 into theta, 90 minus theta divided by g. But multiplying with 2 here, it is u square sine 2 into 90, 180. Sine 180 minus 2 theta divided by g, this one. So then range of projectile R2 is equal to u square. But we know sine 180 minus theta is theta only. So then here sine 180 minus 2 theta, sine 2 theta. Then this is sine 2 theta divided by g. So from these two equations, which one? First equation and second equation, we got range of projectiles, both are equal. R1 is equal to R2. So it means when two bodies are projecting with the same velocity, but with complementary angles with the horizontal direction, the range of the two projectiles are equal. So from diagram, we can represent, see, the two bodies landing on the same point on the ground level. So that's why R1 is equal to R2. Then this distance we should take here, R1 is equal to R2.